Hello 108 students, Mr. McCue here back with you. Hey, we are going to go ahead and wrap up section 1.4. We're going to tackle like terms here. We talked about in the last page, and of course this will finish up page 2 and finish up chapter 1 once we finish up here. So let's just make sure we review this fundamental concept of algebra. It basically is a way to describe when you've got variables. They are called terms, and when you have got the same base for the variable, same base variable, and you've got the same exponent, then you can combine them, meaning adding or subtract. So if they ask you this question of 3x and 4x, are they like terms? The answer is yes. Why? Same base variable, same exponent. You can say, hey, wait a second, I don't see no exponent. You have to always remember, if you do not see an exponent, you can assume it to be equal to what? 1. There you go. So now you've satisfied the two requirements. And can you take 3x and can you add 4x? And of course the answer is yes, because you have the same base, same exponent, and you would combine like terms and write 7x. Okay, you must learn to pay attention to the details. You must have the same base variable and the same exponents to add them or subtract them. How about 7y squared and 2y squared? Are they like terms? The answer is, hopefully you said yes. Y and y, you get the same base. What's the exponents? 2 and 2. So can you take 7 plus 2 and add them up and say 9y squared if you were asked to add them up as an example? Okay, you must learn to pay attention to details like I said before. If I wrote 7y squared and said plus 2y, your answer to me would be what now? Can you combine them? Answer is no, so you'll leave it alone. It's already simplified. Okay, you cannot combine these. Okay, now take this exact same problem. Instead of 7y squared, I wrote 2 and put in wrote 2x. I wrote 7y squared plus 2x. Can you combine them? The answer is no. Same thing. It's already simplified. Okay, now look at this concept. Unlike terms, I've kind of been setting you up here. 3x and 4x squared. If I asked you to add them up, can you? Now you go, oh, I see the same base, I'm all good, but then what? Look at the exponents, pay attention to details. First term is what? A 1. Got a 2. Not the same. Therefore you cannot combine them. Can't subtract them, can't add them. Over here, 7x squared plus 7y squared. Different bases. You stop. Don't be fooled just because you see the same exponents. Okay, you gotta watch those details. These terms would already be simplified if you were asked to add or subtract them. Okay, so I'm taking a look at this example right here at 3x plus 4x. We kind of covered this already, combine like terms. How about this one here? Now, on a whiteboard in class, what I do is I say, do you have the same like terms? Yes, y squared, y squared. Take the 7 and the 2, combine the coefficients, and you write 9y squared. Okay, another way you might see, you see it in the book, they'll take the time and they'll write the coefficients. Remember, coefficients are the numbers in front of the variables. You see 7 plus 2 parentheses, then you see the like term, which is y squared, and finally you see the answer, 9y squared. Okay, many students don't need to really show all this intermediate work here. You'll be fine. I encourage you to go with what's comfortable with the level of work that you show, but as you get back in the speed of things here, you'll be taking 7y squared plus 2y squared and going directly to 9y squared on that. Okay, now let's go ahead and take a look at objective 4 here. I'm going to talk about commutative and associative properties of addition and subtraction. Every course we cover these, and I'm going to try to give you some English translations so that you can kind of take these with you. The commutative property of addition. It basically says it does not matter the order that you add numbers. 3 plus 4 is the same as 4 plus 3 because the result is 7. Okay, so try to keep that. It does not matter the order that you add. Okay, how about multiplication? Does it matter the order that you multiply? If I say 3 times 4, or if I say 4 times 3, multiplication property is commutative, you still get the same results of 12. Okay, now most of you are pretty comfortable with that, so just keep it in mind. But what about subtraction? Is negative 3 minus 4 the same as negative 4 minus 3? And the answer would be what? this would be what? Negative 7. This over here would be what? Convert this to addition. And what did I do? Okay. Looks like I made myself... Okay, I don't like that example. Start back over again. Excuse me. 3 minus 4, is that the same as 4 minus 3? Sorry, just make it easier on myself here. The answer, you can see that the subtraction is not commutative. Here's negative 1, here is a positive 1. Okay, so that's what I want you to get in mind here, that subtraction is not commutative, however, multiplication is and addition is. What about division? If I could squeeze it in here, if I would take 6 divided by 12, or if I said 12 divided by 6. Okay, you know this answer is 2. How many times does 6 go into 12? 2 times. This is a proper fraction. Reduce it down to 1/2, and you can see that these two values are not the same. So, division is not commutative. The order does matter. Okay, now let's go ahead and work on associative property. It's talking about that you're allowed to rearrange the order of when you add numbers. The order doesn't matter how you add them up. 2 plus 3 plus 4. In your brain, you mentally got to take either the 2 plus 3 and get 5, then add 4, which will produce a 9, or maybe you like to work backwards and you would say 4 plus 3 is 7. 7 plus 2 is 9. You get the same answer no matter which way you go. That's what the associative property of addition is telling you. When you add numbers, the order doesn't matter. You'll still get the same answer. Multiplication, same idea. You can associate. Here, multiplication, the same idea. Let's just work this example out. 2 times 3 times 4. I could do in my head mentally 2 times 3 and get 6. 6 times 4 and get 24. Or I mentally could come over here and choose to go backwards from right to left. Say 4 times 3 is what? 12. 12 times 2, 24. And again, you've just proven the property. Okay, so these are fast reviews here. We got one more last objective here for this section. Going to combine like terms, example 3. And then we'll go ahead and cover objective 5 down here. Multiplication property of 0. Okay, so let's jump back up here. Here's an example: 2m plus 5m plus 3 minus 6m plus 8. Okay, simplify the following expression. Can you combine like terms? You could group them together if you like to write the 2m, the 5m, and bring the 6m all together and group them because they're like terms. So negative 2 plus 5 is what? 3. 3 minus 6 is negative 3. Okay, you get negative 3m. How about this? What numbers do you have left? 3 plus 8 is what? 11. And there you go. You could combine them up here if you wanted to. Sorry, right there. Okay, so a lot of students can look at like terms, look at the coefficients, add them up in their heads and get the answer. Nothing wrong with writing them and grouping them together to help you out. Okay, last subjective class and last property. Multiplication property of 0. Okay, get ready for this one. 0 times anything. Notice the words I'm saying. Equals what, class? 0. Okay, you got it. 0 times anything equals 0. Okay, now you guys all know that. So we're going to wrap it up here. That one is almost a given for everybody. And think of this: when you have nothing and you multiply it to anything, how can you produce anything? Okay, we can't do it. It's as simple as that. Okay, so that's it, class. We've finished up page 2 of section 1.4. We're going to go ahead and move on to chapter 2, and we'll start off with section 2.1. Okay, I'll see you in a little bit.